Hi there, in this screencast I'm going to solve some of the problems you might see on tomorrow's quiz on logs. In the first problem, I'm asked to find log 64 base 4. Well, that's simply the number that the exponent that when applied to 4 results in 64. I happen to know that 64 is 4 to the third power, so that means the log of 64 is going to be 3. Alright, next problem. We're asked to find the log of 1/36 base 6. Alright, well, 6 to the negative 2 power is equal to 1/36. So that means the log of 1/36 base 6 is going to be negative 2. And the first few words in tonight's phrase are if you. Alright, moving on. Farther, let's see, there we go. Alright, now I'm asked to rewrite an equation in exponential form, a log equation in exponential form. So I always start with a base, I raise it to the power that's on the other side of the equal sign, and that gives me the argument of the log. So this one would be 20 to the v power equals u. The next one, following that same model, would be y to the ninth power is equal to x. And that's it for that. Alright, now I'm going the opposite direction. I'm asked to rewrite something in logarithmic form, an exponential equation in logarithmic form. So the first thing I want to do is write a log, write an equal sign, and now I just need to figure out what goes where. Well, the base of the log is always going to be the base in the exponential equation. So in this case, it's x. The exponent is going to be what our log is equal to. So in this case, the exponent is negative 1. So that's going to go right there. And finally, what's on the other side of the equal sign is going to be the argument of the log. So I get log y base x equals negative 1. This one follows the same model. In fact, they all do. The base here is going to be x. The exponent is negative 6, so that's what I put in for the log on the right side of the equation. And the argument is going to be 99. Alright, moving on. Expand each logarithm. Okay. When I have a power, I always move it out in front as the very first thing I do. So in this one I'm going to get 5 log base 8 of a times b. And now I have a product inside the as a log argument, so I expand that by turning it into addition. So I'm going to have 5 log a plus 5 log b, all base 8. And that's that one. The next one, I have a quotient inside as the argument for the log, so that's going to become a difference when I expand the log. So I'm going to have log x base 9 minus log y4 base 9. And then lastly, that 4 is going to come out front and become a multiplier. So my final expression is log x base 9 minus 4 log 9 base y, or log y base 9. The second few words tonight are aim at nothing. And the next problem to expand, I once again have a quotient, so I'm going to turn that into a difference. So I'm going to get that and then each of those exponents are going to become multipliers, and they're going to disappear as exponents. So my final answer is going to be 2 log 7, log u base 7 minus 3 log v base 7. And finally, I have something that involves a cube root. Well, whenever I see a a radical in one of these problems, I know I want to rewrite that in exponential form before I do anything else. So I know that the cube root is to the 1/3 power. So I'm going to rewrite that as then log ABC base 4 all to the 1/3 power. Alright, now I'm ready to start expanding. Begin expanding. So I'm going to take the exponent, write it out front, and then I have a product. So when I expand, I'm going to end up with a sum. And you want to make sure that the multiplier goes with each term in the sum. And that's my answer. Alright, the next few words in tonight's phrase are nothing, you will. Okay, so now we're asked to condense a logarithm. So to do this, we do the exact reverse of when we're expanding. We want to consolidate so that we only have one log, log, left in the expression. So the very first thing I do is, if I have a multiplier, I move them so that they become exponents. So now I'm up to this. And after that, I have a difference, so I'm going to turn that into a quotient inside the log expression. And I'm done. Okay, in the next problem, I have, once again, I have a quotient, so I'm going to, or I have a difference, so I'm going to turn that into a quotient after I take the multiplier and make it an exponent for the argument of the log. And now I'm ready to write my quotient, and I'm all set. Okay, and the next one, I have, let's see, 5 log x base 9, and so I have 2 multipliers, so they're going to come up and turn into exponents. And now I have a quotient, so once again, my difference is going to turn into a quotient, and I'm all set. Alright, in this next one, first thing I want to do is I'm going to, instead of writing those as divided by 3, I'm going to write the divide by 3 as multiplying by 1/3. And then it's clear that I take the 1/3 and they become exponents. And now I have log x 1/3 base 2 plus log y 1/3 base 2 plus log z 1/3 base 2. That's a sum, so that's going to turn into a product. I'm going to do log 2 x 1/3 y 1/3 z 1/3, which is log 2 x y z to the 1/3 power, which is the same thing as log 2 times the cube root of xyz. And the final few words tonight are always hit it. Always hit it. Alright, and then in the final problems here, I'm asked to use a calculator to approximate values for log. To do that, for the first one, I simply do log 12 divided by log 3, and then the second one, I'm just going to do log 26 divided by log 3. And I'd enter that on my calculator, but it's really hot out here, and I think I'm ready to go inside. Alright, hope you found this helpful. Get a good night's sleep, and we'll see you tomorrow. Cheers.